Hi guys, welcome back to Worms Maths Academy. Today we're going to look at different types of functions, relations, domains and implied domains, um, just to see basically what the difference is between a function and a relation, whether a function is a relation is a function, but also we need to know this stuff for inverse functions. So you need to know what a one-to-one function is to find out if it has an inverse function. Yeah, so it's just it's something you really need to know, domains and ranges, as well as functions and relations, because it is used a lot throughout the whole methods course. So you have to really have a really strong grasp, and then once you've got a really strong grasp, later in this chapter we learn about composite functions, which kids probably find the most confusing thing, or pretty close to the most confusing thing in the whole methods course. So very important you know how to do this. So make sure you get a strong grasp of it before you move on to do composite functions. Okay, so a relation is a set of ordered pairs. A function is a relation. So any function is a relation. However, every relation is not a function. That's because to be a function, something has to pass the vertical line test. So if I did a vertical line and it only passes through the graph once, then that is a function. But if I had a relation, like a circle, wasn't a very good circle, you can see here that it passes through it twice. So this here is not a function, it's a relation, and it doesn't pass the vertical line test. That's how we know it's not a function. Okay, if we want to find the domain of something, domain is the x values that we use. So if you look here, I've got 4 sets of ordered pairs, and I want to work out what the domain is. The domain of S, so we could say the domain of S is, so what x values do we use? We use 1. We use 1 again. You don't do it twice, you just use the same number. You don't put 2 ones in there. 3 and 5. So 1, 3, and 5. That's our domain. And the reason it's got these squiggly brackets is because they're just single values, discrete values. So they're not, it's not an interval. It's not everything from 1 to 3. It's just 1. Oops. It's just 1, 3, and that's not 3. 1, 3, and 5. Okay? And likewise for our range of S is the y values that we use. So we use 1, 3, 4, and 6. So 1, 3, 4, and 6. That is our range. We could have also plotted these points. So we could have quickly drawn up a mini graph. Actually, I only need it in the first quadrant. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 1, 1, 1, 3, 3, 4, 5, 6. Now the x values that we use, we could see if we did a line, oops, go, and okay. First time we use an x value is when x equals 1, then 3, then 5. So that's our domain. And then our range, the first time we use a y value is 1, then we use it again at 3, 4, and 5. So that's our domain and range. Of course, we've also got it written here. Okay, so just like before when I said, if something's going to be a function, it's got to pass a vertical line test where it only passes through the graph once. That passes through it twice. However, here, it passes through it once. No matter where I put a vertical line, it will only pass through it once. So when we have a function, we can write it like this, f of x. So f is a function of x. It means all of your f of x's or your y values are determined by x. So this is our dependent variable because it depends on these x values and there are independent variables. So if I said you to find f of 3, then that means wherever I've got an x, I replace it with a 3. So 3 squared minus 2 times 3, 9 minus 6 is 3. If I want f of x minus 1, we have x minus 1 squared minus 2x minus 1. You could leave it like that, or we could take out x minus 1 as a common factor. So, x minus 1. So we've taken that out, and we've taken out one of the x minus 1s. In the next bracket, we're left with x minus 1 minus 2, which is x minus 1, x minus 3. F of negative 2, so that means wherever you've got an x, you replace it with a negative 2. Negative 2 squared minus 2 times negative 2. That's 4, and that is 4 plus 4. So we get 8. Don't forget, when you square a negative number, it always becomes positive. If you put in your calculator negative 2 squared, it will say negative 4. That's because it thinks you want the negative of 2 squared. If you put negative 2 all squared, which is what we actually want, it will say positive 4, because negative 2 times negative 2 is positive 4. Okay, so here's our instructions on how to define these and how to test them. So x squared minus 2x. So in your Casio, all I do is go x squared minus 2x, interactive define as f of x. Then we want f of 2. Did I have f of 2? F of 3. So f of, you can just redo it, f of 3, f of x minus 1. Oops, put too many brackets. Go. Okay, f of x minus 1. Now that doesn't factorize it. If you click simplify, it does. And then lastly, f of minus 2. There you go. 8, which is what we got. Okay, so once it's defined, you can use it by substituting in any value. Another thing you can do is if you grab this, copy. If we go into our graphing, and clear everything, paste it. If we go back into here, so I'll just go zoom initialize. Now, because I've got y1 is this here, we can also access that out in the main screen. So you can say y1 of 3, and it'll tell us that it is 3y. Why does it tell us that? That's not usually what happens. Let's see. y1 of x, xy. Maybe you have to use the other y. I think that's what it is, y1 of x. Okay, there's your function. So you're going to use y1 of negative 2. That's 8. So you can actually access the function. You just got to make sure that you use the, I think it's frozen. You've just got to make sure that you use the y that's not a variable. Okay, on the other cars, a little bit different. We go tools, actions, define, and then I hate this setup because I don't know how to use it very well. F bracket was curly brackets. X, and then we move across back to our other keyboard, equals. Now it was x squared minus 2x. So we've defined it. And then we go, I wonder what that does. What does this do? Okay, is there an F anywhere? Not that I can see. Kind of stupid, I hate the way this is laid out. Go back. F bracket of, the first one we did I think was 2, no 3. Enter. F of 3 is 3. 9 take away 6 is 3, yep. And then if we did, it's really annoying because it's not very good to copy and paste with either. Okay, so F of X minus 1 and enter. So that's it, it already factorized it for it. This one doesn't have a simplify button. Oh, there's F. So F of, the last one was negative 2, enter, so that equals 8. So that's how you do it on this calculator. Likewise, if you go into the graphing program, so if I go add graphs, and at F1 of X, if I had to put X squared minus 2X, it'll sketch it. And then if I add a calculator, F1 of X, why do I have that extra X there? Hit enter. So that's defined because it's been defined in the graphing program. Okay, so instructions are there as well if you want to pause the video. Here, g of x equals 3x minus 15. Find f of x as 16. So we want to set that. Oh, there's a g and that's an f. It should be the same thing. So g of x, 3x minus 5 equals 16. This is supposed to be an f. I get 3x equals 21. Therefore, x equals 7. F of x is greater than 3. So 3x minus 5, is greater than 6. 3x is greater than 11. X is greater than 11 on 3. F of negative x is less than or equal to 4. So what that means is wherever I've got an x, I replace it with a negative x. So 3 negative x minus 5 is less than or equal to 4. We're going to have negative 3x is less than or equal to, bring that 5 across, it becomes positive 9. Divide the negative 3 across. Now the significance of that is when you divide the negative 3 across, that changes the inequality around. So x is greater than or equal to negative 3. F of 1 on A, so that means we just replace x with a 1 on A minus 5. Of course, that's 3 on A minus 5, or you can put it over a common denominator. 3 minus 5A on A. And you can do all this stuff on the calculator as well. So if we define that function as f of x, set it equal to 16 and solve. So what was it again? 3x minus 5. 3x minus 5. Interactive define. And then if I said f of x equals 16, interactive advanced solve, it tells me what x is. If I said f of negative x is, I think it was greater than or equal to 4, interactive advanced solve, x is less than or equal to negative 3. So you can see how it works, and it's exactly the same in the other calculator. If we put, I think the equation was 3x minus 6, I'm not 100% sure. Select all. Then you go menu, actions, define. Well, just make it, do it the easy way on this calculator. It's really bad because it doesn't have the normal calculator menu, and I just clicked on something I didn't want to. Okay, f of x. Now, because I've already got f of x defined, this will just write over the top of it. And then if I say equals 3x minus 6, hit enter. If I said, oops, here, want to go back a menu. So Algebra Solve. If I want to solve f of x, is greater than or equal to, and then let's say 4, and then we say comma x because we're solving for x, hit enter, it spits out our answer in this case, x is greater than 10 on 3. So it uses the same process as what the other calculator does, it's just I much prefer the Casio calculator because it's much more user-friendly. Okay, here, x squared minus 6x plus 8, f of x equals 0. So in your CAS, you could define that and then say f of x equals 0. Or we can factorize it, so x minus 4, x minus 2 equals 0. So x equals 2 or 4. Now, if we know x equals 2 or 4, we could quickly, when we've got an inequality, so x minus 4, x minus 2 is greater than 0, when we have an inequality, you can't just solve it and say, okay, x is greater than 4 and x is greater than 2. It doesn't work like that. What you need to do is sketch the graph. I'm sure your methods teachers told you this before. 2 to 4, it's a happy face. When is this graph greater than or equal to 0? Oh, sorry, not greater than, just greater than 0. So it's from here, open bracket, onwards. And then it's from here, open, backwards. So we say when x is less than 2 or x is greater than 4. Now we can use this graph for the next question. When is it less than 0? Well, x minus 4, x minus 2 is less than 0 between 2 and 4. So that graph allowed us to do both of those. Okay, test yourself on this one. The range of the function here is x squared minus 2x minus 8. So what we're going to do, if I wanted to find the turning point of this, you know that your turning point, x, is negative b on 2a, which in this case is negative negative 2 on 2 times 1. So my turning point is going to be at 2 on 2, which is just 1. So we know if we go to sketch this graph, it's going to turn around at 1. If we find what f of 1 is, we're going to get 1 minus 2 minus 8, which is minus 9. So we get the point 1, negative 9. Okay, it's a smiley face, so it's going to go upwards on both sides. If I put 3 into it, f of 3 is going to give me 9 minus 6, which is 3, minus 8, which is, what did I just say? 9 minus 6, which is 3, minus 8, which is minus 5. Now, when it's 3, it's minus 5, but it's an open circle. So 3 minus 5. And when I put negative 2 into it, I'm going to get, so that was minus 5, I probably should have written it down. When I put negative 2 into it, so f of negative 2, I get 4 plus 4, which is 8, minus 8, which is 0. So that's going to go up to, at negative 2, it's going to be 0. So our range, I'll put a little line across. When I move it up, the first time I hit it is at negative 9, and that's included. And then the last time I touch it is at 0, and that's also included. So our range is from negative 9 to 0, and it includes both, because this point's included and this point's included. If they manage to trick you, you would put in this point here, which would be negative 5, not included, and up until 0, which you wouldn't have done. Oh, out there, negative 5 to 0. However, we're not that silly. We know that we should graph it, so we got negative 9 to 0. Okay, one-to-one functions. So we know that if we pass the vertical line test, that it's a function. Now we've got another test, which is a horizontal test, horizontal line test, that it has to pass if it's a one-to-one function. So if I draw a vertical line, this is a function. If I draw a horizontal line, it only passes through it once. So this is a one-to-one function. Vertical line passes through it once. Horizontal line doesn't pass through. So in this case here, that one is a one-to-one, that one's not. That's a function, but it's not one-to-one. That's a function, and it's one-to-one. This one here is a function. It looks like it's one-to-one. However, if I draw a line here, I'm touching it like infinitely many times. So that's also not a function. So here we've only got two. That's also not a one-to-one function. So here we've only got two one-to-one functions. Now there's four types of graphs you can have. You can have a graph like that, which is one-to-one, because one x value gives you one y value, one x value, one y value. You can have a many-to-one, so many x values, you always say the x first, many x values give you the same y value, so many-to-one, many-to-one, so they're the same y value. So this is one-to-one, this is many-to-one. You can also have a many-to-many, like a circle. Many x values give you many y values, and many y values have many x values. So here, this one is a many-to-many, and you can also have one-to-many. So one x value gives you multiple y values. So this is many-to-many, and this is one x value gives you multiple y values, so it's one-to-many. They only really focus on one-to-one. And the significance of that, which you probably should have seen before in Year 11 methods, is that you can find inverses for one-to-one functions. So this function here, we want to find out if it's one-to-one, so we can just draw a quick sketch. We know it's a parabola that's been shifted up one unit. So we know it's a function. Is it one-to-one? No. Passes a vertical line test, but it doesn't pass the horizontal line test because it goes through it twice. Okay, 3x minus 2, so it goes through minus 2. I'll just put that in the wrong spot. And it's got a gradient of 3, so it's going to go something like that. You don't really need to know x and y intercepts. It's basically you just need to draw a line. It passes a vertical line test and the horizontal line test. So we can say it's a 1-to-1 function. Negative x cubed. So we know x cubed looks like that. So negative x cubed is just a reflection on the y-axis. So we can scrap this one. Now, does it pass? Oops. Does it pass the vertical line test? Yes. And does it pass the horizontal? Yes. So it's a 1-to-1 function. Okay, this one might look like it's not, but it actually is. If I've got 1 on x minus 2, it's been translated 2 to the right, so x is 2. It's been translated down 3, y is negative 3. Don't forget you have to label asymptotes. And it's a hyperbola, so it's going to be in here and in here, because it's not negative. Okay, does this pass the vertical line test? Yes, with flying colors. Does it pass the horizontal line test? Yes, it does. So even though the asymptotes, they're equations, they're not actually part of the graph, so you don't consider them. So this is a 1-to-1 function. And if you need to, don't forget you can chuck these into your CAS to see if you think it's a 1-to-1 or not. Okay, so here, which of the following are not 1-to-1? So this one here, x squared plus 2, it's been translated up. However, we've got a restriction, it's greater than or equal to 0. Greater than 0, sorry. So if you think about it, that is 1-to-1. Root x minus 1, that's a root x graph, but it's been moved 1 to the right. So that is 1-to-1. x minus 3 cubed. Okay, it's been moved 3 to the right, and it's got the shape of a cubic. We know that that's also 1 to 1. Okay, we've got two of the same graph. We've got x is 3, 2, and negative 4. Okay, it's a positive cubic, so it's going to go like that. Now, if I had x is greater than 0, there's 0. If x is greater than 0, is this function 1 to 1? It's a function, but it's not 1 to 1. So that's our culprit there. This one here, if I said x is greater than 3, there's 3. Well, we know that that's 1 to 1 because it just continues up forever. So that is a 1 to 1 function. So which of the followings are not 1 to 1? This one isn't 1 to 1. You could also test it in your CAS. So x minus 3, x minus 2, x plus 4. So let's have a look in this CAS. Add graph. X minus 2. X minus 3. And then x plus 4. We can, how do you get it to sketch? Enter. Okay, so we knew that one of them was 0, so you'd know there, if you went from 0 onwards, it's not a 1 to 1 function. Now the other thing you can do, how do we go back to? Okay, I want to go back up to where we were before. We can also restrict it by putting in a given line. So that line there. And we can say x is greater than 0. Hit enter. And you can see it's still not 1 to 1. And then, how do I get back up to the graph? Usually you push tab plus. Okay. And then if we did x is greater than, how do you undo? Okay, I give up with this one. Let's go back to the other one. I'll show you how much easier it is in the Casio. Okay, so x minus 3, x minus 2, x plus 4. Sketch it. If we want x is greater than that, we just go into given, x is greater than 0. Sketch it. You can go zoom auto so that it fits. So you can see it's not 1 to 1. Then you can just change this to be a 3. Sketch it. You can see now it's 1 to 1. So much more user-friendly, I think. Okay, so that is 1 to 1 functions, equations, and relations. Next video I'll go through implied domains, which is very important. Okay, good luck with that.